Hello dear students, thank you all for watching my lecture. Today I am talking about physics chapter, HHC physics, past paper, chapter 2, vector. Okay. Today's lecture will be very helpful for you because this is the basic lecture, and if we learn this lecture very attentionally, then it will be really very helpful for you. Let us start our lecture. My dear students, our chapter name is Physics First Paper, Chapter 2. Chapter 2, Physics, First Paper, Chapter 2. The name of this chapter is Vector. We know this is very important chapter for us. If you want to learn physics perfectly and clearly, then my dear student, you must have to learn this chapter very perfectly and clearly. Without learning all the basic and all the pros and cons of this chapter, it will be really very difficult to understand all the physics chapters or physics paper, first paper or second paper. Both paper, this chapter play a vital roles. I think that if you follow my lecture perfectly and clearly, you will understand all the basics, all the pros and cons of this chapter. Okay, my dear student, let us we start our class. As our chapter name is Vector, so before starting this chapter, at first we learn the component, okay, or quantities. Before learning vector chapter, our chapter name is Vector. Okay, my dear student, at first we learned quantities. Q-U-N, quantities. Okay, my dear student, actually, at first we have to learn quantities before learning the chapter. Actually, what is quantities? Quantities is nothing but anything that can be measured is a quantities in our real world. If you measure anything, then you must need with the help of the quantities. With the help of the quantities, you can measure anything. Okay, quantities may be two types. Quantities two types. One is scalar quantities. Another is vector quantities. Okay, my dear student, at first we learn quantities. Quantities may be two types: scalar quantities and vector quantities. At first we learn scalar quantities, then we learn vector quantities. Actually, what is scalar quantities? Scalar quantities, if we represent anything with the help of the magnitude, then the name of this quantities is scalar quantities. Scalar quantities is those quantities that we can represent only with the help of the magnitude. For representation of the scalar quantities, we need only magnitude. There is no need direction. This is very important. Scalar quantities, for expressing or representing scalar quantities, we need only magnitude. There is no need direction. It is very important. Okay. Let us we take some example of scalar quantities. Suppose we take work. Work is a scalar quantity because if we represent work, then we need only magnitude. There is no need direction. That is very important. Work, speed, work, speed, time, work, speed, time, temperature, temperature. Okay, time, temperature. This is the scalar quantities. Moment of inertia, moment of inertia, potential, moment of inertia, potential. This is the scalar quantities. Another scalar quantities is distance. Okay, my dear student, these are the example of the scalar quantities. Suppose work, speed, time, temperature, moment of inertia. This is very important term. This important term comes over MCQ exam. Potential may be three types. One is electric potential, magnetic potential, and gravitational potential. Distance also scalar quantities. Okay, these are the best example of the scalar quantities. If you represent anything with the help of the magnitude, this is the scalar quantities. Okay, now we discuss about vector quantities. My dear student, try to understand and note down and try to memorize this example. These are the best example of the scalar quantities. Okay, now we discuss vector quantities. Vector quantities is a quantities. If you represent vector quantities, then you need two things. One is its magnitude and another is direction. If we represent vector quantities, then we must need two things. This is very important. Two things. One is its magnitude, another is its direction. Suppose if I note here, for representation of the vector quantities, you need two things. One is its magnitude, that is very important, magnitude, and another is direction. These are the two important things that we must need to represent vector quantities. My dear student, always remember that for representing vector quantities fully and perfectly, we must have to confirm two things. One is its magnitude, and direction. One is its magnitude and direction. Without these two things, we cannot able to represent vector quantities perfectly and clearly. Now we take some example of the vector quantities. My first example is displacement. Displacement is a vector quantity. Why displacement is vector quantities? Because if we represent vector quantities perfectly and clearly, then we must need two things. Okay, we must need two things. Now we discuss about what is actually displacement. Okay, my dear student, displacement is nothing but, suppose we discuss why displacement is a vector quantities. Displacement. Okay, displacement is a vector quantities. Now we discuss why displacement is a vector quantities. Suppose a person or a object straight journey from here. This is the initial point. This is initial point. Okay. If a person or anything or any kind of the object is straight journey from point A, then name of this point is initial point. When the object is straight journey from here to here, this is the final point. Okay, if the object or any kind of the body straight journey from here and stop here, then this is the destination, or this is the final point. This is the final point. Okay, this is the initial point and this is the final point. Now, displacement is a minimum distance. Displacement is a minimum distance between initial point to final point. This is the minimum distance. So here we can say that for representation displacement, we need two things. The distance, this is the magnitude. Suppose this is the 5 meter. 5 meter is a magnitude, and initial to final, this is the direction. Okay. So if you represent here displacement, then you must confirm two things. Suppose if any kind of the body is stretched from here to here by this way, this path represents the distance, and this is also a path. This is path also represents distance. This is also a path to go from A point to B point. This path represents, suppose this is the one path, this is 2, this is 3. 1, 2 and 3 path do not represent the displacement because this is a distance, okay? And the minimum distance is A to B, and my red color represent this. This is my red color represent the minimum distance. So this is the displacement. I think that you clearly understand. Okay, now I take another example of the displacement. Okay, suppose if an object is stretching from here, this is the initial point. Initial point. Okay, this is the initial point. And if this body is stretching from here and go to point B, and do not stop here, and comes to point C, and here stop. If this body stop here, then this is the final point. Okay, this is the final point. Now we take a minimum distance from initial point to final point. This is the minimum distance from initial point to final point. This red marker line, red color line, represent the minimum distance. So we can say that A and C, AC represent the displacement. AC line represent the AC represent the displacement. Displacement. Okay. And A, B and C, A to B plus B to C. A to B and B to C, this is represent the distance. Distance. My dear student, I think that all of you clearly understand. If you have any question, then you must write down your comment on the section. Okay, on the comment section. Then I am again repeat this topics. Dear student, I think that all of you clearly understand. Okay, I think that all of you clearly understand. Okay. Okay. So we can say that displacement is a vector quantities. My dear students, this is the example of the vector component. In our next lecture, we learn different type of the vector quantities. Okay. I think that all of you understand these topics very clearly and perfectly. Okay, thanks to me.